Hello everyone, my name is Gopikadi and I'm studying in 7th Sem ISC in SVC. Let us know about pollution prevention opportunities in tanning industry. Introduction. The tanning industry plays a vital role in the production of leather, which is widely used in various sectors, including fashion, automotive, and furniture. However, the industry is also associated with significant environmental challenges, primarily due to its intensive use of water, chemicals, and energy. The tanning process generates large amounts of pollutants, including wastewater containing hazardous chemicals, air emissions of volatile organic compounds, and solid waste such as leather, scraps, and sludge. Addressing these issues is essential not only to comply with environmental regulations but also to ensure the sustainability of the industry. Pollution prevention strategies, including process modifications, material substitutions, and advanced waste management techniques, offer a pathway to mitigate environmental impacts while enhancing operational efficiency. This presentation explores the key pollution sources in the tanning industry and highlights opportunities for sustainable practices that can drive both environmental and economic benefits. Environmental impact of the tanning industry. The tanning industry significantly impacts the environment due to its resource intensive processes and the use of hazardous chemicals. Below are the primary areas of concern. Water pollution. The tanning process produces large volumes of wastewater laden with harmful chemicals such as chromium salts, sulfides, and dyes. Untreated effluents can contaminate water bodies, threatening aquatic life and human health. Air pollution. The release of volatile organic compounds from finishing operations contributes to air quality degradation. Emissions of ammonia, hydrogen sulfide, and particulate matter from tanning processes can lead to respiratory and environmental issues. Solid waste generation. Solid waste from tanning includes leather trimmings, flushing waste, and sludge from effluent treatment plants. Improper disposal of these wastes can lead to soil and groundwater contamination. Energy consumption. The tanning process requires significant amounts of energy for heating, drying, and machinery operation, contributing to greenhouse gas emissions. Toxic chemical use. The widespread use of chromium in tanning poses risk of soil and water contamination. Improper handling can also lead to worker exposure to carcinogenic substances. Biodiversity loss. Poorly managed tannery operations can lead to ecosystem damage, harming flora and fauna in nearby areas. Key pollution sources. The tanning process involves several stages, each contributing to environmental pollution. Below are the primary sources of pollution. Beam house operations, soaking, generates wastewater containing salts, organic matter, and dirt from raw hides. Liming and dehairing produces effluents with high concentrations of sulfides, lime, and organic matter from hair and skin residues. Tanning processes, chrome tanning. The use of chromium salts results in hazardous solid and liquid waste. Improper disposal can lead to soil and water contamination. Vegetable tanning, although considered more eco-friendly, it can generate organic waste if not properly managed. Post tanning operations, pickling and dyeing, generates wastewater with high levels of acids, salts, and dyes that are difficult to treat. Fat liquoring releases oils and other chemicals into wastewater streams. Finishing processes, coating and polishing. Emissions of volatile organic compounds from solvents and coatings contribute to air pollution. Buffing and drying produces particulate matter and dust which may pose respiratory hazards. Wastewater and solid waste generation. Untreated effluents from various stages contain high levels of biological oxygen demand, chemical oxygen demand, and toxic metals like chromium. Solid waste includes fleshings, trimmings, and sludge from effluent treatment plants, which, if not managed properly, can lead to environmental degradation. Pollution prevention opportunities. Process modifications. Adopt water efficient processes, example closed loop systems, use of low sulfide liming methods, switch to vegetable based or alternative tanning agents. Material substitution. Replace hazardous chemicals, example chromium, with eco friendly alternatives. Use biodegradable tanning agents. Technology upgrades. Install advanced wastewater treatment systems. Use energy efficient equipment. Waste management strategies. Effective waste management in the tanning industry is critical to minimizing its environmental impact and ensuring sustainable operations. Below are key strategies to manage and reduce waste. wastewater treatment and recycling. Primary treatment: use sedimentation and filtration to remove suspended solids and reduce biological oxygen demand levels. Secondary treatment: employ biological processes such as activated sludge or constructed wetlands to treat organic matter and reduce chemical oxygen demand. Tertiary treatment: implement advanced methods like reverse osmosis or ion exchange to remove heavy metals including chromium and purify water for reuse. Air emission control: install scrubbers and filters to reduce the release of volatile organic compounds and particulate matter. Use activated carbon systems to capture solvent emissions during finishing operations. Chromium recovery and reuse: implement chrome recovery units to precipitate chromium from spent tanning solutions. Reuse recovered chromium in the tanning process, reducing chemical consumption and environmental contamination. Energy recovery and efficiency: utilize waste heat from boilers or drying processes to reduce energy consumption. Install energy efficient equipment and renewable energy sources like solar panels. Zero waste initiatives: adopt circular economy principles by integrating waste back into the production cycle. Explore partnerships with industries that can utilize tannery byproducts such as agriculture, construction, or cosmetics. Case studies: successful implementations. Case study: chrome recovery in Indian tanneries. Background: many small and medium sized tanneries in India face challenges with chromium contamination in wastewater. Implementation: a group of tanneries adopted chrome recovery units to extract chromium from spent tanning solutions. Outcome: reduced chromium discharge by over 90%, reused recovered chromium in tanning processes, leading to cost savings on chemical purchases. Improved compliance with local environmental regulations. Conclusion: the tanning industry, while essential for leather production, poses significant environmental challenges due to its resource intensive processes and solution generation. However, by adopting innovative pollution prevention measures such as process modifications, advanced wastewater treatment, and sustainable material substitutions, the industry can significantly mitigate its environmental impact. Successful case studies from around the world highlight the feasibility and benefits of implementing cleaner technologies, from reducing water and chemical consumption to transforming waste into valuable byproducts. Moving forward, a collaborative effort among industry stakeholders, policymakers, and researchers is crucial to drive sustainable practices, ensure regulatory compliance, and promote a circular economy. Embracing these strategies not only protects the environment but also enhances operational efficiency, market competitiveness, and long term sustainability. Thank you.